In section 6.2, we're going to be looking at properties of rational exponents, and this isn't really any different than what we've done before, because we already spent time going over properties of exponents, and so now those same properties are just going to be applied to the rational exponents that we talked about last section, so applying those properties to the exponents that have fractions in them. So this list of exponent properties should be familiar. It's the exact same one that we used in the last chapter when we started looking at properties of exponents. Just to highlight a few, remember that when we're multiplying with the same base, those exponents get added, and when we have an exponent raised to an exponent, they get multiplied. That seems like that's the most common mistake, to mix those up, to get those switched around. So just be careful when you do those. I think the rest of them have typically gone pretty well. We still will occasionally see negative exponents, but I don't think as often in this chapter. Okay, so all of these same properties will be applied to the fraction exponents that we've been looking at. The examples that we'll see won't look that different than ones we have done in the past. Again, we'll just have fraction exponents. So here we have a base of 7 in each of these exponents, and so we know that we can add the exponents. So it's easier when it's something like 7 to the 4th times 7 squared, because 4 plus 2, that's 6, so we would have 7 to the 6th. But when we have fractions aren't our best friends, so it takes a little bit more work to add these fractions. Some of you can probably do these in your head, but here we'd have 1/4 plus 1/2. Common denominator would be fourths, so that's 2/4. So here we have 7 to the 3/4. And just for the sake of connecting it to the other things we've been doing with the roots, don't forget that this could be written as 7 cubed with the 4th root of that. Those would be equivalent. In this next example, we have 6 to the 1/2 times 4 to the 1/3, all squared. So here we have two different bases. We have 6 and 4, so those cannot be combined into one exponent since the bases are different. So here all we can do is send that squared into each of the exponents that we have there. So 6 to the 1/2 times 2. 1/2 times 2 is just 1. And then that's times 4 to the 1/3 times 2. 1/3 times 2 is 2/3. And that's about as simple as we can make it. Since it's 6 to the 1st, we could ignore the 1st and just leave that blank. But that's as simplified as we can make that one. Last example here, we have 2 to the 1/4 times 8 to the 1/4. Now if you compare this to the one before, you might think that we can't really go anywhere since we have a base of 2 and a base of 8, so we can't combine those in any way, so we're stuck. But with a little bit of creativity, we can keep going on this one, because 8 is a power of 2. So here we have 2 to the 1/4 times 8 is 2 cubed. So all I've done there is rewritten 8 as 2 cubed. So we have 2 to the 1/4 times 8, or 2 cubed, to the 1/4. And now we have the same base, so we can start combining things. So we have 2 to the 1/4 times 2 to the 3/4, because 3 times 1/4 is 3/4. Then those exponents get added. So we have 2 to the 1/4 plus 3/4, which is 4/4, and 4/4 is 1. So we have 2 to the 1st, so this is just 2. So that one takes a little bit of creativity, or just being able to see that one of these is a power of the other and can be rewritten to look like our other base.